Hi, today we're going to be taking a look at these Stihl brand Bluetooth ear protectors. Now somebody brought these in to the repair cafe where I volunteer at, and what we discovered was the battery needed to be replaced because, if I just zoom down a bit there, if I just look here, we can see this MOSFET has actually exploded. And the cell did look a little bit puffed up as well. So we ordered a new battery for them, which we fitted, but they still don't work. So I got asked, could I bring them home and have a look at them? So I thought, well, we'll do a video on them and we'll see if we can repair them. So let's have a look inside. I shall just grab a screwdriver. Let's move these screws out of the way. Right, so this is the new battery pack fitted. We'll just put some tape around it to hold it together, and we soldered the existing battery plug onto it. So what happens is, if I just get my little USB tester here, I'll just plug that in. When you plug it into charge, we'll get the green light comes on, but it doesn't draw any current. And also, it doesn't switch on or do anything. That's literally it. So all that happens is, when we put it on charge, the green light comes on to see it's charging, but it's not drawing any current and it's not switching on. So let's see if we can figure out why and if we can repair it. So there's two circuit boards in here. This one contains most of the Bluetooth stuff, and this one's just the speaker and what appears to be the charge controlling board. So we'll remove a couple of screws that hold this in, and I might bring the microscope in so we can have a look over this. I mean, there's not a great deal on it. It's not a very complicated circuit by the look of it. So, right, I'll just go and set the microscope up. One moment, please. And resume. So, I've taken the circuit board out of its little orange housing just so we can get a bit of a better look of it here. This is where the battery comes in, and this is where the charger comes in. It looks like the charger goes through this fuse here, and we've got a, looks like a reverse polarity diode there in case somebody plugs a different charger in, that's a different polarity. Then it looks like the power comes in here, on this rail here from the charger. Goes up through here to the battery by the look of it, and also to this IC here. It looks like we've got a battery protection IC, because I recognise the number now, the DW01, and what that does, it disconnects the negative of the battery if the cells are over voltage or under voltage, and that's controlled by these two pins here, which then control these two MOSFETs. So the negative from the battery comes in here, goes through the first MOSFET, so if the chip's happy it switches it through, and then if the chip's happy with this condition it switches it through here, and then that goes to the negative of the circuit board. So if the chip detects an abnormality, it'll either switch off that MOSFET or switch off that MOSFET and basically disconnects the battery. Right, what else have we got then? That looks like it could be a temperature sensor, which goes to this chip here, a 130E, which I'm not sure what that is, but it could be some kind of charging chip. and then we've got these wires here that go across to the other side of the headset, and I think we've got power on these two. I think that one's, was it the yellow? Yeah, I think the yellow one was the charge indicator. I think this one was for a microphone, but it's not used. And these two go to the speaker here, which I've just got disconnected at the moment. And I think it shares a common ground between the speaker and the microphone, because I think these are linked together. Right, let's do some measurements then. Let's get the meter on it. So let's see what we've got in the pack first of all. So a little test point here and there. So we've got 3.7 volts in the pack. Let's see if these MOSFETs are switched on. So if I go to the positive of the pack here and go to here, yes. So it looks like the battery protection IC is happy with the cells, because it's switching the negative through these two MOSFETs here to here. So what we should get up here is 3.7 volts going to the other side of the board. So let's have a look here. And we don't have anything. Do we have anything here? Yes. So we've got 3.7 volts to here. This looks like it goes to this transistor here, yeah. And then it looks like this transistor here, or MOSFET, switches the power from here to here, but it doesn't look like it's doing that. Let's try plugging the charger in, and we'll see if we get voltage up to this IC here. Right, so I'll just get the charger plugged in. Right, that's the charger plugged in now. Right, so let's have a look here then. So that's the positive. Well, that's odd. Why is the red wire? Yeah, that's the red wire there. And that's the black wire. And I thought that looked like ground, but it's got a red wire going to it. But it's actually the correct way around. It just looks like they've used the wrong colours. That kind of confuses a little bit there for a moment. Yeah, because that's definitely ground and that's definitely the power. Right, so looks like the power comes in here, goes through this fuse. Yeah, we've got 5 volts there. I remember I had a bit of an issue with one of these fuses on another thing that I looked at. I can't remember what it was now. What was it again? That was the Milwaukee vacuum I looked at, where the fuse was actually letting power through, but just not enough power. The voltage was correct, but it just wasn't actually letting any amps through. It's the first time I've came across that, so that kind of threw us a bit as well. Alright, let's see if we get any power to this IC. Yes, we've got 5 volts there. Have we got anything on this pin? 3.7. So I guess that's the output of the charger. That's the temperature sensor. Let's see if we get anything on these pins up here now. No, we've got nothing on those as well. Right, okay. So it's not charging and we don't have any power. So I'm kind of suspecting this IC possibly here. I'm just wondering what these transistors here are for. What I think's going on is when you plug the charger in, we've obviously got power on this line here, which then switches negative to through this transistor to the, looks like the base of this one, which would then switch positive from the battery from here up this pin here to the base of this transistor, or the gate if it's a MOSFET, which then switches the power from there to there to the other side of the board. It's kind of what it looks like. So I wonder if this is a way, so when you plug the charger in, it disconnects the battery from powering the actual unit, so it's not draining the battery at the same time as charging. I think that's what it's doing. But it definitely looks like this IC isn't working properly. The 130E. So I think the first thing is that I'm going to do is see if I can find a data sheet for this IC and possibly order one, and then I think we'll continue from there. Right, it's been a couple of days and I managed to get hold of a replacement IC. One of these battery charging chips here. So I'm going to use some low melt solder. I'm just going to add a little bit of flux to this IC first. And then I'm going to use some low melt solder just to help remove it with the soldering iron. There's a few plastic connectors around here. I think this will be the safest way to do it for now. And there we go, easy as that. It's good stuff, this low melt solder. If you're after any of it, I'll leave a link in the video description. I'll just clean this off first. Right, I'll use a little bit of IPA now. Right, I'm going to tin these pads up now with some leaded solder. Let's add a bit of flux first. Right, let's get the new IC in place. Right, I think that'll do. Right, we'll try my new rework station. Right, let's give that a touch of a clean up now. Yeah, happy with that. Right, let's plug the battery in. And we'll plug the charging port back in. And then we'll see if we get any voltages on things. See, that one's starting to come out a little bit. Right, let's get the test meter back on. And let's see. Oh, actually, if I just get the USB meter here, I might be able to see this. I'll just try and get the USB meter in there. It's actually drawn 0.46 of an amp now, so it's actually charging. And it wasn't doing that before. Alright, let's see. Let's just see if we get any voltage on here. Right, well, there's no voltage there, so let's unplug this. And let's see if we get any voltage on here. Yes, 3.7 volts. That's better. Right, so it was that chip that was faulty. But I'm starting to suspect that somebody has plugged the wrong charging lead into this. I think somebody's plugged the wrong charging adapter into this. because the charging chip's damaged and also the MOSFET on the battery was exploded. So I think somebody's plugged the wrong charger in. Right, I'll just get this out of the way. Right, so when you plug this in now, I notice the light seems a lot brighter than it did as well. Right, so let's just check we've got voltage going up to here again. It's a bit harder without the microscope. Let's try this. Right, so yes, so we've got 3.7 volts coming out of this board now. There could be a break, actually, well, yeah, it could be a break in the cable possibly. Right, I think we need to have a look in here now. So I'm fairly happy that this side of it's actually working now, and now we've got problems in here. Right, let's take this side apart. Let's zoom down a bit. Right, well that was my tea just done there, so I've just finished that, so we'll continue with this. Right, so this board just come out. There we go. Then we'll unplug this little microphone. And we'll unplug the speaker one here. Right. There we've got that board free now as well. Let's move these screws out of the way. Right, let's have a look over this then. Again, not a lot. Let's zoom down a little bit. So it looks like we've got a small IC there, and by the look of the capacitors around it, I would kind of hazard a guess at that being some kind of audio amplifier. And then it looks like we've got this Bluetooth module here, a BM20 by Microchip. Right, and we'll see if I can find a data sheet for this, and we'll see what voltages and whatever we're supposed to have on this, and we'll check those with the meter. Right, I'll be back in a moment. Right, so I've printed out a pinout of this BM20 module, where the voltages come in, where the reset pin is, and it's got a couple of outputs as well. Sys power, which is a power output, and a 1.8 buck converter output as well. So I'll put this to one side where I can see it, and then we'll check some of these voltages. Alright, so try and get the meter in shot as well. Right, something a bit like that. Right, so let's first check that we're getting power to this pin here, which is where it comes in from the cable. Yes, we've got 3.75 volts there. Right, so is this using battery in, I guess, which is pin 21, which is the third one from the end here, so where this capacitor is. Yeah, we've got 3.7 there. So we've got power to the module. Let's check this pin here, which is sys power. Nothing on there. Nothing on there. Right. So this is the power on off button. Let's see if we get anything there now. No. So where does that go? Actually, it goes to one of the LEDs here. That's where the sys power goes. You can just see it comes along here to that wire there, and then through the wire to the LEDs. out of those two LEDs, sorry, on the outside. Yeah, because I think the centre ones are the charge ones, so I guess the other ones must be either power and possibly Bluetooth status, I don't know. Right, so let's just see. If we get anything on adapter in, which will be the next pin along here. I mean, we haven't actually got the adapter plugged in at the moment. Well, it doesn't quite look like that pin's being used. So I tell you what, we'll plug the adapter in. And that's the green charge light coming on. Let's see if we get anything on adapter in now. No. And we don't get power to that pin now either. And so it does isolate. I'll tell you what, I'll plug the adapter back in. We'll just see if we get power here now. That's slowly going down. That's probably just the capacitor there. And when we unplug the charger, yes, so we're getting power to this chip. It just doesn't seem to be switching on. I'm just wondering if this chip has failed. Let's just see what the reset pin measures, just in case it's being held in reset. So that is this pin here. Which is actually at 0 volts as well. I wonder if it's being held in reset maybe. I'll just zoom down a little bit more, see if we can have a look. So we do have a wire there. This must be a multi-layer board or something, because there's no wire on this side. Actually, yeah, there's a test pad there for reset. So I just wonder if it's being held in reset possibly. I can't even tell if there's a resistor there, is there? No, there's no resistor there on the reset pin. So I guess that pin's not being used. I'm starting to think this module's failed internally. Tell you what, I'm just going to disconnect the power going to it. Let's just try seeing what the resistance of the module is, just in case there's a short or something. I'll just zoom out the fraction. Well, that looks okay. And 3.2 ohms. Looks a little bit low, that. And this is on the sys power, which is the power output from this IC. 3.2 ohms. See the ground. Let's see what this one does. This is the buck converter output, which is 1.7 ohms to ground. I mean, I'm not sure if that's normal or not, but I wouldn't have thought so. That seems very low, that. Let's see what the next pin up is. I'm not sure what this one does, but I mean, that's the kind of reading I'd be expecting, something like that. Well, that seems very low, 1.6 ohm and 3.2 ohms, because those should be power outputs. In fact, if that's supposed to be lighting up the LED, 3.2 ohms isn't very much. I mean, there's a capacitor there. I mean, it could be a shorted cap. I think I'll get the bench power supply and we'll try injecting some voltage on this pin. And it says on the data sheet it's supposed to be between 3 volts and 4.2. So I'm going to try injecting 3 volts on that pin there and we'll see what happens. Alright, I'm going to set the bench power supply up. Right, I've got the thermal camera set up. I haven't applied any power to it yet. And I've got the power supply set at 3 volts at 1/4 of an amp. So I'll just switch the power supply on there. And the voltage has actually gone down to 0.73 of a volt. And it's taken the 1/4 of the amp there, the 250 milliamps. I'll just try turning the current up a little bit. Right, I think that's the problem. Nothing else is getting warm on the board apart from that chip, so I think that kind of confirms it. There's an internal short in that IC. I'll just knock the power supply off there. Right, I'll just stop that. Right, so it looks like I'm going to have to get one of those ICs, one of those modules, and hopefully it doesn't need programming, because I was reading the documentation that you can program them for different ports and that and stuff, but hopefully they've just used it as is and it doesn't require any programming, so we'll have to see when it arrives. Right, I'll go and order one of those then. So it's been a couple of days and I've managed to obtain one of these Bluetooth modules from DigiKey. So let's get it out of its packet. Oh, got some desiccant with it. Oh, it actually hasn't got any shielding on this one. Well, that one's got shielding on it. Let's just zoom down a bit. That's a little bit of a pain. Oh, I wonder if the shielding is actually going to make any difference. I wonder if I can remove the shield off this one. I think I'll have a go at removing the shield off this first. I might bring the microscope in again for this. Right, one moment please. So I thought I'd remove the shield. So I've just gone across it with the soldering iron there and just heated it up so I can remove it. Just to have a look under here. And look what we've found. There's a big hole blasted in this chip. So the battery charge IC was blown. The battery MOSFET was blown. And there's a big hole in the Bluetooth chip. So I definitely 100% think this has had the wrong power adapter or something plugged into it. And it's basically fried all of the chips. I'm not sure about this chip here. Fingers crossed that this one is okay, because that gets fed from that power rail as well. I'll have to look up the number on that. That's a P8908. I say I'm fairly sure it's some kind of audio amp by the look of it, but I'm not 100%. Right, I think what we'll do next is we'll remove this module and see if I can fit the new one. Right, I'll get the rework station out. Let's put a bit flux around this first. So yeah, almost certainly that's what's happened. I mean, the module actually wasn't too badly priced. I think it was only about £10 for the module. So I mean, all in all, it's still actually working out cheaper than buying a new headset, because I think the headsets retail for around about £80 to £100, and for all the parts so far, it'll be about £20, I think. I think it was about £10 for the battery, maybe £10 for the Bluetooth module, and I think it was about £1 for the charging IC. Right, let's get the rework station out. Right, I'm just going to use some solder wick and we'll just clean off the old solder here while I'm knocking that capacitor off. Right, I'll give that a bit of a clean up with some IPA. Right, I'll tin these connections up with some leaded solder. Let's put a little bit of flux on there first. Right, I think that'll do for that. Right, we'll see if we can get the new module in place now. Let's spin it round. I'm just going to put a bit of flux on the back of this first. I'll see a little bit of a nudge over. Right, I think that looks about right. Alright, we'll heat it up. I think I might just touch up some of these pins just to be sure. Let's do the other side. This side actually looks a bit better. Right, let's give it a quick clean up. I think I've missed a pin there. Actually, maybe one there as well. Right. Let's get the microscope out of the way now then. Right, and I'm just curious to measure what the resistance is on that cis voltage there. And that looks a lot better. It's not a couple of ohms now, is it? What's the next one up? Even the next one up's K as well. So, right, let's plug the battery in that in and see if it does anything. Because the only thing I'm concerned about is there's a flash chip here and if it contains a special program or not. It still appears that we're not getting any power lights or anything, so that's not good. Let's see if I get any voltage on this cis pin. And we do. Nothing on the 1.8 pin though. So I'm wondering whether that flash chip has been fried, because we could still remove this chip from here, the flash chip, and transfer it over to here. But judging by the hole in this chip, I just wonder if this one's been fried as well, because it would have had the same voltage going to it. So I've got a feeling that that chip's going to be fried as well. Right, I'll have to have a think on this one. Right, so I thought I'd take the chip, the EEPROM, off the old Bluetooth board and try it in the programmer just to see if it had any data on it still or if it was blown, and amazingly it seems to be intact. And I know it's correct because if we scroll down through the data here, in a moment you'll see, there we go, I think I've just gone past it, there we go, still dynamic Bluetooth. So I know the data is actually correct. So I've saved a copy of the data just in case we damage the IC. So what I'm going to do next is just remove the IC from here and solder it onto the new Bluetooth board, and then we'll try it. We'll see if that makes it all work. To make this a bit easier to remove, I'm just going to put some leaded solder on this chip first. It's got a bit of a lower melting temperature than the lead-free solder. So something like that. Then we'll get the rework station out. Right, there we go. Right, I'm just going to add a little bit of flux now. And use a bit of solder wick just to get rid of the old solder. Now, was there a component there that's blown off? I'll have to have a look back at the video just to double check that. I'm just going to put some fresh solder on here first. Right, let's get the original. Tell you what, clean this up first with a bit of IPA. And I'm just going to add a little bit of flux to that. I'll probably do with a little bit more solder on that end pin. Right, something like that. Right, I think that's it. Right, let's give it a test then. Let's just cool down there now. So let's plug the power lead in and see if anything happens now. Oh. Yes, I think it's working. At least it's doing something now. Right, let's hook the speakers back up. Yeah, that seemed to switch off as well. Yes. I was getting a bit thingy that wouldn't be to fix this one. Right, let's just plug this in. Let's plug the microphone in. Actually, that board could just sit in there now, like that. Because it goes that way anyway. Well, I can't hear anything. would have thought it would have made a noise or something. Let's just plug the other side in. Not unless the audio amplifier's gone in it as well. Wouldn't surprise us. Let's get this unplugged in. Right, I'll tell you what, I'll just go and grab my phone and we'll see if it detects and if we can pair it or play some music through it. And one moment please. So I thought I'd get my phone and we'll try. See if we can get this into pairing mode, which I believe is that. Right, I'll hit scan. And there, it's found it there. Let's see if we can pair to it. Right. Well, I just noticed the volume pop up there. I don't know if this is on or off. Yeah, that's off. So that's on. And because little Bluetooth signs came up there. Oh, there we go. The volume just came up there a second ago. I wonder if I've got to be playing something. That's better, there we go. Right, the up and down volume's working. But we're not getting any audio. There should be some music playing there now. Nope, nothing coming out of here. Nothing's ever straightforward. Right, I think because I've got the pin out of this chip, the speaker left and right are on 7 and 9. So I might hook the scope up and we'll see if we're getting the waveform out of this Bluetooth module. I've got a feeling it's going to be this audio IC next. I think just everything's just been blown up on this. Right, I'll go hook the scope up and back in a more. Right, so I've got the scope hooked up and this IC here is a P8908. I'll just zoom down a fraction. And the audio comes in on this from the Bluetooth module on this capacitor here and this capacitor here. So if I go on to this pin here, and if I look at the scope, you can see the audio changing there. So we know the Bluetooth module's working and sending audio to the IC. If we go on to this for the other channel, there we go. We can see audio coming out of the Bluetooth chip going to that capacitor as well. Right, the next thing I'm going to do is just check the voltages on this IC, just to check that they're present, and then we'll check the output of the IC. So I've just had another quick look at the data sheet, and the power for this chip comes in on that pin there. So if I measure across this cap, I'll just zoom out a bit to get the meter in shot. So if I measure across this cap here, right, so we've got 3.7 volts going to the chip, but we've got no audio coming out of it. So I think we need one of those chips as well. Nothing's ever straightforward. Right, I think I'll have to see if I can order one of those chips and then we'll continue the video. Well, it's the following day and I managed to get some chips sent out. So they've just arrived. I got these from Farnell, so So let's see if we can get this IC off and fit a new one. I'm just going to put some flux on here. Alright, let's heat this up then. Right, I'm just going to get rid of this old solder and put some fresh leaded on. It looks like the thermal pads just came off. It doesn't look like solder's sticking to this board very good for some reason, I don't know why. Just give this a bit of a clean. And try a different tip in this iron. Right, let's get the replacement IC. Right, I think that should do. Let's put it back together then. So I've just put this back together just to try it, and it didn't work, but I've just noticed I've got a bridge between these two pins here. So I'm going to use the iron and a bit of flux, and we'll just see if we can get rid of that bridge. I'd really like a bit more solder on some of these pins as well. Right, let's see if that works then. Been a bit of a nightmare repair, this one. Yes, I heard a noise. Right, I'm going to quickly pop this back together then, and then we'll try connecting the phone up to it. Right. So I'm just going to find some copyright free music. I need to connect to the Bluetooth headset. I need to switch it on as well. It's automatically connected, that's good. Right. Ew. Is that because the volume's up too high? Yeah, it doesn't sound very good. I don't know if you can hear that. It sounds pretty horrible and distorted, that. Right, I'm going to have another look at this then. Right, so I decided to change the audio chip again, just in case those shorted pins had caused any damage. So let's just quickly couple it up again once I get this microphone plugged back in. And I'll just put a couple of screws in just to try it, just to keep it together. I don't like the way this board kind of sits up. It doesn't actually sit on the pegs. It's actually like hovering above. Right, let's see what it does now then. Well, we'll get the noise again. That sounds better. Let's put it up with the microphone there so you can hear. Let's try the other speaker. Right. Well, this has been a bit of a long repair. Just switch this off, and then I think it's just a matter of putting the top back on here, and we're done. I'm glad I got another one of those chips, because I normally order 2 just in case, because I mean they were only 70p each, but the postage was a little bit extortionate. So right, let's just try this one more time. Yes, and we'll just see if it plays music okay. Right, like I said, bit of a long repair this one, so all good at the end of the day. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.